Hello everyone, we are happy to welcome you today for our meetup about data science. So I'm happy to welcome our speakers of today, Oriol Roquet from VP Tech and David Suarez from Appium Hub. So before beginning, I'm going to share my screen. Can you see my screen? Yes, I think so. Okay, I'm going to start. So today our topic will be modelization and personalization in data science. So to begin with, I'm going to give you some quick best usage for the live. So during the presentation, please stay in the projection room, put the full screen to have a more comfy live by clicking on the blue button on the right of your screen, as you can see in the screenshot below. And in case of troubles, refresh your PIs. Otherwise, don't hesitate to contact vptech-communication@vp.com. And at the end of the presentation, you will have an open discussion with Oriol and David. So during the presentation, you will not be able to ask your question. So I invite you to write your question on a paper or on your smartphone to share them with our speakers of today. And at the end, you will be also have the possibility to visit our VP offices. Before beginning, I'm going to do a quick presentation of the platform itself. So the platform, it's called VP Quest, made by Work Adventure. We launched this concept in 2021 because we wanted to create a space when all the VP employees could meet virtually. So as you can see on this screenshot, we represented all of our VP Tech offices. We have 11 offices all around Europe, and they are all represented virtually in pixels. So VP Quest is a friendly virtual space when you can have common areas for private conversation up to 4 people. So you can talk to every people you want to meet, and then you will have a discussion as you want. You can also have meeting rooms up to 200 people if you want to a meeting like right now, by example. And you have also the possibility to go in the silent zone if you don't want to be disturbed, if you have a meeting. And voila, just like in real life, so you can talk to each people you want. You can walk all over the room, and don't be disturbed if you want to be alone. So VP Quest, we wanted to launch a multicultural space with all the VP countries represented. So we wanted to represent all of our environment and be able to visit all the offices and to meet all of our colleagues all around Europe. And thank you for your attention. Now I'm going to stop sharing my screen and I will let Appium Hub starting with David and Ivan. Thank you.
Thank you very much, Luis. This is Ivan. On behalf of Appium Hub, I would like to thank VP Tech for hosting this event. I'm sure this is going to be really interesting. For those who doesn't know Appium Hub, we are a software company based in Barcelona. We focus mainly in software architecture, software development, and data science. Our main goal is to offer our clients the best experts to help them transform ideas into powerful and scalable products. And in today's meetup, we have David Suarez. He is a data scientist at Appium Hub. He's going to present a model in production with a model monitoring platform called APORIA. So I hope you all enjoy this event. And David, all yours.
Okay. Hi, everyone. I'm going to share my screen. Okay. So hi, everyone. I'm going to talk about model in production with APORIA. First of all, I'm going to present myself. I'm David Suarez, data scientist at Appium Hub. Before, I have been working for 5 years in the deep learning area in BBVA Innovation Labs, BBVA Bank. And the beginning of my work, we always had the same problem. We need production models in production, but we needed to try different models with different libraries, and we didn't want to depend on the library platforms. So today I'm going to present a model and a platform that for me it has a very important point. This platform is agnostic model. So this allow us to choose the library that we want to build our model and to put it in production. So I'm going to explain very quickly an example and how you can integrate your model with the platform. And at the end of the presentation, you can ask more deeper questions about the platform if you want. So the first point is why I choose this platform. The most important point is because it is agnostic, as I said. But it has 2 important points. The second one is the easy integration, because it is not difficult and you can integrate your model very quickly. And the last point is the monitoring options. It has many monitoring options that you can set up in exactly for your problem.
David?
Yes.
Hello, excuse me to bother you. It seems we've got an issue with your screen. Can you unshare and share again, please?
Yes.
Sorry about that. And maybe do not activate your camera again. Maybe it's going to work better.
Okay. Now? It's okay? Can you see my screen?
Yeah. Yeah.
Okay. Okay, so very quickly, the introduction, again, 3 important points: agnostic models, easy integration of your model, and many monitoring options that you can set up. Can you see my screen?
Yeah. Yeah.
Okay. So very quickly, the first point is again integration point that we have divided in 3 points: INIT model, model version, model schema, and your predictions. So in the first point, INIT model, I'm going to explain how you can add your model. This is the APORIA screen. You have a button here where you can add your model, and you have to follow three steps. The first step is get your token. Aporia identify you by your token to init exactly one model. So at the beginning, you have to copy this token to put it in your code, and after that, of course, you have to import Aporia and install it in your Python libraries. And after that, you have to go to this is the init Emporia import. You can set up your environment, and after that, you have to define your model version schema. As you can see here, you have your version. This can change if you want to try different models. And here you have your model type. In my case, this model is regression model. And all your input data for your model. You have different kinds of data: categorical, numerical, Boolean. You can choose. There are many types. Here you define your prediction value. In my case, is a sales value. And very important here is the model version, which you defined before, and the model ID that that identify exactly your model and with the version. In the next step, you have to send your predictions. You can send your predictions. You have to when you receive a petition for your model, then you build your JSON with all the features and your value predictions, and then you define an ID exactly for these predictions and the time that it occurred, and you send to Aporia. This is because you can send what they call actuals. Actuals is when you say the predictions, you after maybe 1 day or 2 days, maybe you have the real value, and then you can send back the real value to compare with the predictions that your model did. So the only important point that you have to remind is that you have to send the same ID to identify your prediction value. Okay. So quickly we go to the code and we go to Aporia. I want to show you. I'm not going to get very deep into the code, but just to check some point. This is my Jupyter notebook where we can see a normal model, and here you have the init Aporia code where you init your model with your token. Here you have your schema. I report the regression model schema. And as you can see here, you feed your model, check your results. You can code wherever you want. But important is at the end of your train, you can send the training data set to Aporia. You can send all the features and the labels. It will be private, and you don't have to mind about about your data, but you can
David,
yes.
excuse me to disturb you, but are you sharing something on the screen? Because for now we can only see go to code and APORIA on the slide 2.
Yes, I'm
Are you
sharing.
sharing?
Okay, I will share again. I will stop and start sharing again. Okay. Can you see my screen now?
No.
Okay, let's see.
Can you share your entire screen
Yes, I
instead of
did
just
that.
a window?
Okay, 1 second, because maybe I will try. Now you can
Yes,
see my screen,
we
right?
can see your
Okay.
screen right now.
Okay, let
Yes.
me copy the tab.
Yes, I can see token authentication is enabled. It's
Okay.
that page.
1 second, because it's in another tab, and I think the application is not getting the. Okay, now can you see my code?
Yes, perfect. Thank
Okay.
you.
Sorry, everyone. What I was showing is the code that I was explaining. So very quickly, because I don't have enough time. This is the code for INIT APORIA. This is my report schema with all my features, all the model ID and the model version. Here, as you can see, you can code whatever you want about you can feed, check results, compare your model, paint and different graphics. But another important point is you can send your training data set and your test set to Aporia. And after that, you can check the graphics in Aporia website. Here we send the actuals, which is the real value that we got about our predictions. And we are going to the Aporia website. This is the dashboard, the main dashboard of Aporia. Here I have two models. I want to share with all of you the model example that I sent to Aporia. The first point I wanted to show is here you have all your precisions and measures about your model. Here you have all the different versions. You can have different versions of the same models. And here you can see the last predictions that the petitions that your model receives in the last 24 hours. Here you have different monitorings, but I want to show you all the options about monitorings that you can set up for your models. Here you have prediction drifts, data drifts, model activity, freshness, mixing values, which is very important, and data drift. You can set up different monitorings and monitors values, and you will have different alerts. As we can see in this model, for example, we have many alerts open because I wanted to show you all the difference. And you will receive an email each time alert will be on. So this is the part of alerts, and you have also data stats related to the training data that you sent, so you can check everything here and different versions that your training data set that you sent. And I think that's all the most important points. To finish the presentations, I just wanted to show you the last part that Aporia is setting now, which is data segments, where you can make a different business intelligence with your training data sets and get informations about also your predictions. So with this very quickly presentation about the platform is all that I wanted to show you. If, as I said, if you want, I will be able now for more questions, more deeper question about the platform. So thank you, everyone, and I think Oriol is going to follow me.
Thank you, David, for your presentation. If you have any question, as I said before, don't hesitate to ask them after Oriol and David's presentation. So now let's move on with Oriol and his presentation. I'm going to share my screen again. Can you see my screen? Yes.
Yes.
Okay.
Okay. Okay, this doesn't work. Okay, so thanks everyone for joining today. Thanks, David, for your presentation. It was really interesting, actually. So today, so I'm Uri or Uriol. I'm based in Paris right now, but I came from Barcelona. And I've been working in as a data scientist for VP for the past 2 years and a half. And right now I'm in a customer experience optimization. There's some other people here. Thanks for joining. And our main project is personalization, which is the thing that we're going to discuss today. But it's true that we also have other side projects, such as churn prevention and affinity targeting. So this is the agenda for today. So a little bit of an introduction first. Then we'll see learning to rank, and finally, our approach in the personalization. So the scope for our personalization, it's mainly and most importantly for the homepage. So this is a typical homepage of a VP platform. So we have different sections, in this case, like the new sales that we have available, and we have other sections as well. And our goal here is to provide personalization in this homepage. So each customer that registers in VP will have a different order for these sales.
Sorry, Ariel, there is an issue with the sharing screen again.
Okay.
I'm going to share my screen again. Like this.
Okay, is it okay now?
Wait, I'm sorry. Normally, usually should be okay now. Yes.
Yes? Okay, perfect. So as I was saying, we have the homepage in which we provide some personalized content for the customers. But it's true that at the same time, we have some communication, such as emails in this case. So the sales here are also personalized for each member. And right now, we operate on 7 countries. 3 of them are recently new for the personalization scope. And in total, it's 10 different sites. So for instance, in Privalia, we have Privalia MVP in Spain and Italy. So these are 2 different sites and so on. So what is our goal? So we have customers, we have different sales available, and our objective is to provide this personalized ranking in order to increase the conversion rate. So this means that we want that from customers that access the website or the platform from the application, to make sure that we increase the total number of buyers, so customers that in the end purchase something. But this has to benefit all business units and all customer segments. And we need to also take into account the SLA. So our service needs to be quite fast. We need to provide the personalized ranking in 100 milliseconds. We can have peaks up to 200 requests per second, especially when sales open at 7 a.m. We have a lot of customers accessing the website at the same time. So we need to handle this as well. And this service needs to be 99.9% available. So here's what could, for this customer, an example of the personalized ranking specifically for her. These are the latest results that we have. This is for the test that is currently ongoing. Again, here we monitor different KPIs, but as I said before, the most important one is conversion rate. But it's true that even if that is our goal, we also increase or not decrease for the average order value, other KPIs as well. So let's start with the learning to rank. So let's see how we actually can provide this personalization. And first, we're going to discuss the classic approaches, which is the ones that we don't use. But it's important to understand them because this leads us to why we choose to do our own method. So the first one is content-based. So imagine you have a customer. This customer has purchased this set of items. And we see that we have another item that is quite similar to the items that has been purchased in the past. So we can recommend this item directly to this customer. But here we have 2 different problems. The first one is the bubble effect. So if we go for this approach, these recommendations are always similar to the old purchases. So there's no new discoveries for this customer. And the other issue is there's really low diversity. So these recommendations are like in clusters. Another classic approach is the collaborative filtering. So imagine we have two customers, and we see that these items have been purchased by both of these customers. So we can assume that these users are similar. So what happens if the user A has bought another item? We can try to recommend it to the other user because they are similar, so maybe she will like it as well. We have two problems here. The first one is the cold start. So if an item has not been purchased, we will not be able to recommend it. And for the other issues, the lack of context. So imagine if we are going to recommend a swimsuit that was purchased at summer, and we are trying to recommend it at winter. Maybe it's probably not the best time to do it. So what is our approach, the BP approach? So we have customers, we have items, and what we do is we try to compute distances based on affinity. So the idea is if a customer and a product has a higher affinity score, it means that we'll generate more interest to this customer rather than another one. And this is based on user description, user behavior, campaign description, campaign performance, and context. So in this case, the closer the affinity, then it means that we're going to try to recommend this item. And in our case, we don't have products, we have sales, as we've seen before in the homepage and the emails. This is inspired by net triplet loss, sorry. So the idea here, imagine we have on the top left, we have two images from Donald Trump and one from Emmanuel Macron. So the idea here is we have an anchor, and we define what would be a positive and negative item. In this case, positive item related to this anchor, it's the other image of Donald Trump. And the idea is that we'll train some model to make the model understand, that the positive item it's closest to the anchor than the negative one. And this is done in this case, since this is images by convolutional neural networks. But the important thing here is that the weights of these networks are shared between each other. And finally, it computes a triplet loss. That it has this formula here. I'm not going to be into too much details, but it's in our case, we modified a little bit this triplet loss. And what we do is we forget about the anchors, but we have this positive and negative items. And this is the most important part, in my opinion, of the way that we do the recommendations. So now that we have the basics, let's see. First of all, we need to select the positive and negative items for our model to train. Okay, so we have a user. We have some sales available in the homepage in a given time. And the way that we select the positive and negative items is if a campaign has been purchased. So imagine if the user has purchased something from the Tommy Hilfiger, we will consider this as a positive item, positive interaction. And then for the negative can be any one of the remaining sales that has not been purchased. So in this case, we can select, for instance, Pepe jeans. Now, with our items already selected, we can compute different set of features. So in this case, we have the context. So the hour of the day of the week, section, minutes in sales opening, and so on and so forth. These kind of features are computed in a stream, so while the model is in production in real time. Then we have user description, so registration date, age, gender, and so on. But also, most importantly, user activity. So if a user has purchased a set of items, or maybe has built a little bit more of a brand rather than another, all this kind of information that can make a model more reliable in terms of understanding what the user prefers. Then we have the campaign description itself. So each sale can have a brand, business type, sector, subsector, a duration, country, and so on. For all these three types of features, they are all computed in batch. So this means that we just compute them once per day. Then we have the campaign performance. So how a sale performed. And here we can have two different things. Either a sale is currently live and we compute, let's say, what we call popularity features. So this means how much turnover or how much orders do we have in the last 1 hour, 15 minutes, and so on. So this is compute in stream, but it's true that at the same time, we also try to take a look at the past and see if similar sales per brand or per sector, to see what was the true performance by that time. So we have some information, especially when the sale starts, from which we don't have popularity features available at that time. And finally, apart from this global popularity, we also have popularity per clusters. So in this case, we can imagine that people that from the age from 18 to 25 years old might be interested in some specific sales, and this might not be related to the sales that other group of people would like. So this we also take into account. And of course, this is also computed in stream. So now that we have all these features, we need to train the model. So we have the positive item, the negative item, we have the context, and the user. And what we do, as we saw before with the shared layers of the previous slide, we have two different neural networks here, but the layers are shared between them. So when one will input the features of the positive item, and the second one, the features of the negative one. And here, the idea is to maximize this difference between the score of the positive item and the negative one. So we can be able to better differentiate and, of course, make sure that the score for the positive item is higher than the negative one. So we'll have a way to compare between different sales. And this is what we call this affinity score. So now the model has been trained. So let's do some predictions. Imagine we get a user that connects to the platform, and we have a set of sales that they are not ordered yet. So what we do is, okay, let's take the model that has already been trained, and we go one by one. So for instance, the first sale, gives us a score of 51. Okay. The second one is the score of 12. So this means that the user would have more interest in the Épicerie Corse sale rather than the Finsbury. And we can do this with all the available sales. So for instance, 87, in this case, 83, 92, this is the highest score so far, and 6 for the middle, so this is the lowest one. So from all the sales that we have seen here, the item, so this one, has the highest score. So this means that this is the one that's going to be on the top of the homepage, while the casa is going to be on the bottom of it. So this is how the personalized order for this customer would look. But it's true that this personalized ranking remains unchanged for 30 minutes. And this is because if you are in the website, you're looking for different things. Maybe imagine that you enter in a sale, you take a look at the products, and you come back, and then you try to figure out where was the sale that you were on. So this is a little confusing. So that's why we keep it like this for 30 minutes. And finally, just take a little look for the schema of our pipelines. This is a simplified schema. So for the training pipeline, everything is computed in batch. So we just used, of course, historical data, and this comes from our data warehouse. We have some processing step here, which afterwards generates data, data sets for our model. And we have a final offline evaluation step to make sure that models have a minimum performance. Once the model is trained, we can add it into the serving pipeline, so model in production. Here, things are a little bit more complex, because since there are some features that needs to be computed on live, we need to retrieve this live data. So this means that the same features that are computed in the training pipeline needs to be computed in two different processing steps, one for the batch processing that runs once per day, and the other for the live stream processing, which is run on live. So with this information, we add it into the model that has already been trained, of course, And this here would be able to provide the predictions for our customers. In our case, we also have two different evaluation steps whenever a model is serving. So the first one is purchase replay that allows us to see, even if a model is not in production, but it has already been trained, we can check how we can fit the model that has already been trained with data coming from the serving pipeline and see what could be the theoretical performance in terms of min rank and so on and so forth. But of course, for the business side, what we do whenever a model is in production or we are doing some A/B tests and so on, we have a dedicated monitoring platform for A/B tests in which there we compute the business KPIs and so on, which is the first or second slide that I show. And that's all. Thanks.
Thank you, Ariel and David, for your presentation. Now let's move on for the Q&A session. If you want to ask some questions to our speaker of today, I'm going to show you how to join this room right now on my screen. So as you can see, for the meet and talk, you just have to follow the VP staff in pink and join the second meeting room. And don't forget to open your camera if you want to, and your mic if you want to speak directly to our speaker, David and Ariel. So just hop off in the meeting room in top of this one. See you.